In this video, we're going to talk about the different classifications of matter. So matter is anything that has mass and occupies space, so it has volume. So the first question you ask yourself when you're categorizing it is, can it be physically separated into new substances? If it can't be, then you have a pure substance. If it can be, then you have a mixture. First, we'll talk about the pure substances. So if there's only one type of atom present, you have an element. And within elements, there's two subcategories. You have elements that are monatomic and diatomic. If they exist as diatomic, that means when you find them in nature, they're going to be paired up as two atoms of that element. So we have the Brinkelhoffs, which are all of the diatomic elements, which include bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Anytime you find them, they're going to be found paired up. There are monatomic elements, which is the rest of the elements on the periodic table. An example of that would be iron, where you find is a single spherical thing. Okay? And then if you have two or more types of atoms that are chemically bound, you have a compound. And those have chemical formulas. So there's two real types of compounds. You have molecules, which are made up of only nonmetals, which are things to the right of the staircase on the periodic table, like carbon dioxide. They have a beginning and an end. Okay, like CO2 would be an example of that. And its formula, its structure would look like this. So when you're looking at a formula, the subscript always indicates how many atoms of that element exist in the substance. And then we have formula units which we use to describe the crystal lattices of ionic compounds. They don't really exist with a beginning and end. Like when you hear sodium chloride, it's not just one Na and one Cl. It's really a huge crystal lattice of all these things. And the smallest ratio of the elements in the lattice is called the formula unit. So those are the pure substances. If you have two or more types of pure substances in the same sample, you have a mixture. In those mixtures, if they're uniform in composition and properties, we call them homogeneous. And if they're made up of a solute and a solvent, we call it a solution. Okay? Example of that would be Kool-Aid, 14 karat gold, or other alloys, steel, which is a mixture of iron and carbon where they're uniformly distributed. Okay? That's the key thing here. And if you have a solution that's homogeneous, that's basically a liquid solution, it's going to be translucent. Light will pass through it. It might have a color, but light will be able to pass through without getting scattered. If you have something that's not uniform in composition, we call it a heterogeneous mixture. And if it's heterogeneous, it's going to scatter light. So it can appear uniform, and in that case, it's a colloid, which consists of medium-sized particles that don't settle out over time, like milk, some types of jello, fog. Milk has a whole bunch of stuff dispersed in it. It's not truly dissolved. Like salt water, you can see through it. The salt is truly dissolved. In milk, you have proteins and fat molecules that float around, truly aren't dissolved, but are just dispersed and appear uniform, but they scatter light. Suspensions will settle out over time and usually consist of more large-sized particles or things that are completely insoluble. So you have things like Italian salad dressing, where if you shake it up, it may look uniform temporarily, but it will settle out over time like a suspension. And then you see granite, which you might think, how does that settle out over time? It's already settled out over time. You can see the distinct parts. So not uniform in appearance would be a suspension. All right, now let's take a look at a couple different atomic arrangements that we could have. An element, if you have two molecules that consist of the same type of atom, each one with two atoms, you would write the formula as 2W2, 2 indicating the number of molecules, the subscript 2 here representing the number of that type of atom within the molecule. If you had two different molecules that consist of two different atoms, but they're the same, so this would be a compound. So two molecules, each one with one black and white, and the other one with the same, so you would say 2BW. So you could physically separate these things, yes, but you wouldn't be separating them to new substances. And that's why we call these two pure substances. And now we have a couple of mixtures that are a little bit more confusing. So here you have, say, O2 and O3. Those are both different allotropes of oxygen. O2 being diatomic type you breathe, O3 being like ozone. Clearly two different substances with two different properties. So even though there's only a singular type of atom present, the fact that they're in different arrangements means that this would have to be a mixture of two different pure substances, even though there's only one type of atom. And then if you have a mixture of, these two things would both have the same chemical formula of BW2, you would have to call it a mixture and not a compound because they're both arranged differently, just like this case, and these are called isomers. So isomers are molecules that have the same chemical formula but different structural arrangement. And a real-world example of that would be these two isomers of C2H6O, where one would be ether and one would be ethanol.